and execute it. You can also start to build up roles so that your run lists don't become enormously long. You can start to say, well, what does my web server look like? Well, it's got a base role, which is shared across all the machines, and it's going to run Nginx, an Nginx server. And then you could define your base role, and here again, I apologize, this is obviously a Red Hat machine, but here's an example of a base role. And the base role simply contains the run list. So roles themselves can be nested, and this introduces the idea of knife. So Chef has a command line tool called knife, which allows you to do pretty much anything you can imagine in the Chef world. You can control, upload systems, configure systems, run things in parallel. Knife is kind of the main interface as a sysadmin that you would use to manage your systems. So in this case, we've written a role, which is just, if you look at this, this is actually a text file. It's a Ruby DSL. And the text file will get uploaded using knife, gets uploaded to the machine using the API, containing all of this stuff and all these nested bits and pieces. And now we can say that we want to use a role instead. That's not what that slide says. Oh, I see the slide. The next slide shows this. So, excuse me, an important thing, and this is a very fundamental philosophical point about Chef, is that these will always be executed in order. So one of the fundamental things about Chef is that one Chef run will always give the same results every single time. So it's completely repeatable, and it's always in the same order. And that's a fundamental, primitive principle of the way Chef works. So Chef has now got a role base and a role web server. It results in the same thing, it's just easier to manage and easier to see. And there we are, we've got a database role, and now the database role is including the MySQL database stuff, and we've got two different nodes, and it's the same kind of basic pattern. Okay, so I mentioned that things are indexed. This is where we start to get really very interesting. So when you provision on clouds, or in a software as a service thing, I don't know whether you've used the Joint Cloud, or Alistair's Cloud, or any kind of system where you're provisioning some kind of utility computing, you don't generally know what your IP address is going to be, do you? So if you don't know what your IP address is, how are you going to point your web server to its database? Well, either you need to fire up the machine, go and have a look, I see what the IP address is, and go and enter it, or you need some kind of dynamic DNS mechanism where your machines are launched and somehow it registers and you know, or you can search for it. And this is the secret sauce. This is what enables system integration. Because frankly, configuration management is really easy. There's not really very much to it. But the integration of all those pieces into a complex way which makes your system work, that's the hard bit. And that's the interesting bit. So if we look here, all this kind of stuff represents what your system looks like. And if our database server and our web server are provisioned in a cloud, how are we going to find it? Well, here's how you do it. You can search for nodes having a certain role. You can find configuration data, because every single piece of information about your machine is stored on the Chef as metadata on the Chef server for you to search. This includes IP addresses, it includes host names, it includes FQDNs, and all sorts of other bits and pieces. And so what that means is you can do something really smart like this. You could have HA proxy set up for your load balancer. You could specify that your pool members are going to be search an index called node for all machines having the web server role. This will now give you back an object which represents every single pool member that you have which has the role web server. We can then configure our HA proxy, and we can specify that the pool members should be a unique summary of these. And what that means is that you can add a machine, one sec, you can add a machine or subtract a machine, and every time Chef runs, the load balancer config is dynamically generated. There's a question.
Okay, let me check if I could answer. It seems to me that you use Ruby as a script language to have these templates files. Is this correct?
So the question is, are we using Ruby as the configuration file.
Yes.
So Chef is fundamentally a set of DSLs, domain-specific languages. They are actually Ruby. This is Ruby, but it doesn't look like Ruby. You don't need to know much Ruby in order to write it. But this here, for example, do and end, gives you a clue that this is actually just Ruby. Now, Ruby is a particularly useful language for writing DSLs. And what that means is that whenever we need to, if we want to, we have the power of Ruby available. But 95% of the time, we can use the DSLs which have been provided. And this ERB, that's an eRubius or an embedded Ruby template, which allows things to be dynamically generated, just as you would with Mason or any other kind of template. Does that answer your question?
Right, yes. The thing is, I like the idea that you have templates, examples that you can download directly from the community. I like it. But I don't understand how the templates that, for example, if you want to configure Apache on a machine, then on, for example, Linux, you have certain configuration files that you have to touch. And this is something standard. But then there's information that is peculiar to your installation. How do you put these two things together?
Okay, that's an excellent question. The question is, how do we take the standard stuff, which is always the same, but also allow for the fact that everybody has some unique stuff in their infrastructure? And this is the exact problem that Chef was built to solve. So Chef separates configuration from data. So data over here is the stuff which changes and the stuff which is unique. We can have this, we can store it on the Chef server, we can store it on a machine which we can retrieve via an API, you could have it in a CMDB, you can put it wherever you like, anywhere where you can reach into it. And then you have the stuff which doesn't change, and then you add the secret source and you tie it together. And one of the ways that you might do that is using search. So that's exactly the problem that Chef is designed to solve. Hi.
The communication between the Chef server and the agent, does it use its own protocol?
The communication between the Chef server and the client is the question. The communication between the Chef client and the Chef server just uses HTTP. All right. So what we're going to do then, we're going to search for these pool members, and we're going to pass the results into the template. So this is an example of a Ruby template that you would use with Chef. So this is basically an HA proxy config, and all of this looks pretty much the same apart from this little bit here and this little bit here. What we're doing here is we're saying specify for every instance of the pool members, iterate over it like a for loop. For every one, drop off the member host name in this file. So if you've got 7 servers, this will generate a configuration file with 7 server entries. And then what we're going to say is, if we specified, this is an attribute, if we specify an attribute that the admin interface for HA proxy should be enabled, then ensure that we're listening on 2202 using HTTP, providing statistics on the root URI. This here is an example of using conditional logic. This here is an example of using an iterator. So here's another example. Quite often what we want to do, especially as we're building dynamic infrastructures, is we want to say, a machine has been built, it should be in monitoring straight away. We don't want to say, and John and I used to work together many years ago, and we had a massive build sheet where you build the machine and then you'd have to go through the tick list and you'd have to set it up in DNS and set it up in CMDB and make sure it was in monitoring and make sure it was in backups. It would take about, well, a day if we were quick. What we would do nowadays is you just say, machine is launched, straight away it goes into monitoring. So here's how this works. This is the Moonin server cookbook. So what we're saying is, if this cookbook is evaluated on the machine, specify that the Moonin server, that it's specify that it is a Moonin server. So set the attribute Moonin server to true. Okay? Now we're going to search for clients. We're going to search for clients, and the way we're going to do that is by saying, is there an attribute called mooning client true on that machine? So any machine that we build that we want to be monitored, we just make sure that in its chef config, mooning client is set to true. Now we're going to drop off a configuration file called etc.cron.d mooning, so it's the cron job that runs mooning. We're going to specify some attributes about it and where it comes from. And then we're going to specify the mooning configuration file, and we're going to pass in the mooning client variable, which we obtained from search, into the configuration file. Very simple. What that means is that every time Chef runs on the Chef server, it will go and look and say, are there any new clients available? Oh yes, they are. Great. Configuration file set, and if you looked further down on the recipe, you'd see it would then restart the service. Here's the mooning client. So we're going to set the mooning client to true, and we're going to do the same thing. This time, we're going to search for the mooning servers. If the mooning server is set to true, that means we know this is a mooning server. Now, unless that search was empty, i.e. there are no mooning servers, then what we're going to do is we're going to install the mooning node package. We're going to drop off a rendered configuration file. We're then going to specify and pass in the mooning servers that we got from search. We're going to restart the mooning node service, which we've defined down here. So now what that means is, every time a machine is built, it goes straight away and says, are there any mooning servers around? Ah yes, there's one, great. And straight away, mooning node will start, and it will start feeding it data. That's how we do it. So, when this becomes this, that happens automatically. So, let's count the resources that we needed to change to happen. We needed to change the load balancer configuration. We needed to change the Nagios host ping monitor check. We might want to check SSH. We need to change HTTP. Maybe there's an app health check. And then there's some graphite stuff. CPU, memory disk, SNMP, Memcache, Postgres firewall rules, Postgres auth configuration. This is for one node edition, 12 or more resource changes, but actually it just happens without us ever needing to do anything at all. So, questions. Who was paying attention? What is a node?
A server.
Yeah, a server. A node is any machine that we're managing using Chef. So it could be a physical Solaris machine, or it could be a zone or container. It could also be a switch, or a managed router, or some other such thing that we never run Ruby on, but we can still capture information about it and store it on the Chef server so we can find stuff out about it. Okay, what's a resource?
That's a quick question, go back to the switches.
Yeah, go ahead.
How do you manage it on the switches?
So on a switch, say we've got a switch and we want to know some information about switch ports or whatever. We can't run Ruby on that switch, and so we don't run the Chef client. But what we can do is we can get information about the switch, either by SNMP, or perhaps there's an API on the switch, or maybe we can scrape the web interface, and all that information can go into the Chef server. And so you can have a node representing that switch, and all the information about that is there, and anytime information changes, it gets updated on the Chef server. And what that means is the rest of our infrastructure can now use that data in its dynamic configuration. So what's a resource?
A service running on the server?
A service running on a server. Yeah, so a resource is basically just anything that we might want to configure. An example of a resource, a package, a user, a group, a service. We can also have Git repositories or DNS API calls, HTTP requests. These are all resources that we can manage. So what's a recipe?
Several resources.
Yeah, a set of resources. A recipe is the list of things that you need to do in order to cook up your infrastructure, which specifies all the resources that need to be done, how they need to be done, and in the right order. That's a recipe. And how is it different from a cookbook? Yeah, cookbook contains recipes. It's a set of recipes, exactly. So what's a run list?
Series of actions.
Yeah, it's a list. It's a list of things, a series of actions. You're saying this node should have the